All right, so today I'm going to talk about theorems of the predicate deduction system. So a theorem of PD is just a sentence that can be derived from no primary assumptions, or in other words, it can be derived from the empty set. It's like the conclusion of an argument with no premises. And because we have this relationship between the syntax and the semantics, in other words, between the semantics of the language PL and the syntax of the language of this derivation system SD, we know that any theorem is a sentence that is true in any interpretation, right? So no matter what interpretation we can build, finite or infinite, that theorem, that sentence is always going to be true. It's going to be true in all of those interpretations. So the way that we would prove that a sentence is a theorem is by doing a derivation and showing that it can be derived with no starting assumptions. And the way that we would prove that it is not a theorem is by building an interpretation that makes it false. Okay, so let's look at an example. A lot of the time, what you want to do is look at these and see whether it sounds like something that's always true. You know, if it sounds like a theorem, then you want to start by trying to prove it. And if it sounds wrong, if it sounds like something that's, you know, shouldn't be true all the time, then that's then you want to start by trying to build an interpretation, or start by trying to build a counterexample. So what does this say? It says everything in the universe of discourse is F, or everything is not F. All right? So that's definitely not a theorem. In fact, it's really easy to build an interpretation that's going to make this false. We just need an interpretation with two things in it. Okay, so let's kind of sketch out our interpretation here. This will be the extension of F, okay? And let's put Albert in F. We'll put Betty out here. Okay? So there's one thing that's F, and there's one thing that's not. So it's not the case that everything is F, and it's not the case that everything is not F either. So this is false, right? So this interpretation, if I asked you for a counterexample to show that this is not a theorem, we have this interpretation where Albert and Betty are universal discourse. That's who we're talking about, or what we're talking about. And the extension of F is just Albert. Or more technically, the order tuple with Albert in it. And there you go. This is a counterexample that shows that this is not a theorem. Now, on the other hand, this is a theorem. Everything is F, or not everything is F. That just has the form P or not P, which you might remember from doing sentinel logic. And it's really easy to prove. In fact, we can prove that this is a theorem without even using any of the new quantifier rules that we've learned. So this is a pattern that might be familiar to you by now. We want to prove that all X are F, or not all X are F. Okay? And to do that, we have to prove the opposite of what it is that we're trying to prove. That's the only way we can really proceed here. Even though this is a simple derivation, unfortunately it takes a lot of writing. It's kind of a drawback of predicate logic. Okay, this is assumption for purposes of negation elimination. Okay, pardon my board management there. Okay, so now we have to make another assumption. Let's go ahead and assume, say, not all x are fx. We'll assume that for purposes of negation elimination again. I think everybody kind of knows where I'm going with this. Now I'm going to use disjunction introduction to get what's in here, to get this negated sentence here. Okay, so it's just disjunction introduction on line 2. All right. Now, I have to reiterate this into here. It's reiteration line 1. Okay, so I have my contradiction here. I can close out this subderivation and conclude all x fx by negation elimination lines 2 to 4. Okay, so now I just repeat the same thing that I did in here. Okay, disjunction introduction, line 5. I'm going to reiterate line 1 down into there again. And I'm done. I have a contradiction again, and I can go ahead and close this out. I can go ahead and close out this subderivation and conclude this. Lines 1 through 7, negation elimination. Okay, and there we have it. We proved this theorem of the PD system. It's true on every interpretation. And notice that we didn't even use any of the new quantifier rules. We used just rules that we knew back before the second exam.